Okay, in this problem, we can see that we have a charged particle, plus q, and it moves with the velocity through a region of uniform electric field directed to the left. So my electric field is directed to the left, and anytime I have a field like that, like if I know, let's see if I can draw here. If I know my field points this way, I always think about it like the field in between a capacitor. So I kind of think like there's a capacitor plate here and a capacitor plate here, and I know the electric field points from positive to negative. So I just like to draw this out for myself, so that I remember what's going on, and I can, if I forget what direction the charged particle moves, this really helps me to remember. So I know that I have a positive charged particle. So I know that the charged particle then is going to follow the electric field because it wants to go towards the negative charge on this plate. There's a uniform, right, and then we have a uniform magnetic field directed out of the page. So the charge will feel no net force if the velocity vector has a magnitude of, so it's asking me about the velocity, and it wants to know which direction it's going to be going in. So if I look at the answers, it's going to be either moving upward or downward. So we can just try. We'll start with upward. So let's say I have my charged particle right here, and it's moving this way. So what happens is I've got a force. I know that there's going to be a force due to the electric field, right? Looking here, over here, there's going to be a force directed to the left on this charged particle, but it's already moving it's moving up. So if it's moving up, that means it's going to be pulled. It's going to have something that looks like this, like it's going to be pulled that way. So what we want to do is we want to have this magnetic field pull it back this way, have a force on it that's directed. So if I have a force from the electric field this way, force electric, then I want the magnetic field to point this way, the force B to point that way. And that way, if that's true, then the electron or the positive charge will just go straight through my fields. So if I want to see what direction the B field, if the B field is correct, if I'm moving in the right direction, I can point my finger up. That's the direction the charged particle is going, and then the B field points out of my hand, or in my middle finger represents B, and then the force is to the right. So did I guess right? I did, right? Because if my charged particle starts below, then the force is going to be to the right here, because I'm going to have the force, B is out of the page, and then F is to the right here. So that's great. So I know that it's moving upward, so I can cancel out the ones that it's moving down. And now how do I figure out what V is? Well, I know that force is equal to, for the electric force, it's equal to QE. This is F electric. And for the magnetic force, it's equal to QVB. That's the magnetic. So I set those to equal, right? My Q's cancel. And I'm left with V is equal to E over B. And so E over B, that looks like it's A.